Hi, everyone. My name is Anais Rameau. Thank you for the introduction. I will be presenting Myophonics, a device for the future of voice rehabilitation. I am one of the co-founders. Can you imagine living without your voice? Unfortunately, that was the plight of my grandfather, who was a poet, but also a smoker, and got a laryngeal cancer, which had to be removed in the operating room. And when he came out of the operating room, he looked the same, but he had lost his voice. He's the reason I decided to dedicate my career to restoring voice. The focus of Myophonics, though, is restoring voice for patients in the ICU, because currently there are no good communication tools in the ICU. This impairment in communication leads to bad things, such as complications from prolonged ICU stay, oversedation, and also extubation delays. Our solution is a non-invasive wearable device that translates articulatory muscle activity into speech. The value of our device is better patient assessment in the ICU through better communication, decreased complication rates, speedier extubation, and also improved quality of life in the ICU. We are seeking seed funding to accelerate the development of our wearable device, as well as collecting more data for the improvement of our AI algorithm and work towards FDA approval. Currently, patients who are in the ICU have a tube between their vocal cords. That means that they are no longer able to produce a voice, and they need to communicate, oftentimes by squeezing the hand of their caretakers, such as in this video.
Can you squeeze my hand? Good. I'm going to ask you to squeeze my hand every time I say the letter A. So when I say A, what will you do?
This is a very limited way of communicating. Some patients in the ICU have a tracheostomy. Oftentimes, this tracheostomy cannot be fitted with a speaking valve because these patients are being ventilated or they have too much secretions. Some individuals have tried to innovate in the space of communication by using the electrolarynx, such as in this video. Unfortunately, the quality of the speech produced by the electrolarynx is extremely limited and is not a good solution. Outside of pandemic times, there are many tracheostomy and intubations occurring just in the United States. About 100,000 tracheostomies occur every year, and 1 million patients are intubated, and that's not during COVID times. There are other patients also who require a voice, but are not a current focus of our startup. That includes patients with a stroke, patients with laryngectomy, and patients with severe hoarseness. The ICU remains a large unmet need. The average ICU stay in the United States is at least $6,900 a day. And each day spent in the ICU increases the complication rates and the mortality risk, as displayed on the graph on the left-hand side. The inability to communicate in the ICU leads to preventable adverse events, errors, and delayed diagnosis. In addition, about a fifth of patients currently in the ICU will develop PTSD as a result of their ICU stay, and in great parts because they could not communicate. The Center for Medicare and Medicaid Services, as well as commercial payers, are currently reimbursing according to patient satisfaction. Our solution is a wearable device that's composed of a disposable component that is placed on the patient's face with embedded electrodes that can be tailored to the patient's anatomy. This disposable wearable is connected to a hardware device that is non-disposable that processes the electromyographic data signal from the muscles and translates it into a speech through an algorithm.
Yes. No.
This translated signal is then communicated through Wi-Fi to tablets or a speaker. We are using a unique and patented cascaded algorithm that pre-processes the EMG signal and identifies specific features of speech. Currently, our classification of 10 digits achieves 92% accuracy on several individuals, which is not an easy task to complete. We have some competitors in this arena. This includes invasive competitors, which are on the left bottom hand side of the screen, including larynx and the tracheoesophageal puncture valve, which require the presence of a laryngectomy. Voxello is another competitor. This one is a digital communication board, and it requires high dexterity with for the patient to be able to select the words they want to communicate through a tablet. VoiceIt is not a competitor. VoiceIt is a translation device that allows to translate unintelligible speech into intelligible speech, but it requires an audible voice. Other competitors similar to ours are Altec and the MIT Media Lab Alter Ego. Neither of them have a product on the market. And as you can see, their device is not user-friendly and would be difficult to use in the ICU. Syrinx is a new product that is being developed in Japan and has an entirely different goal. It aims to restore voice in outpatients and especially cancer patients. Myophonics is very unique in this space of sign and speech and provides a comfortable solution. Our value proposition includes a clinical value. Patients and family are empowered. They can now communicate with their caretakers in the ICU. We are also aiming to reduce ICU-related PTSD and improve end-of-life communication when patients may want to express their wishes. There is also an operational value with improved workflow with nursing staff who can now better understand their patient's needs, and also reduction of preventable adverse events as patients can now communicate their discomforts and their needs. There is also a financial value with increased patient satisfaction. We're hoping to also increase hospital CMS reimbursements. We also aim to reduce error, adverse events, and prolong ICU stay. And finally, there's already a CPT code that exists for speech generating devices, which is well reimbursed by Medicare. This is our team. I am delighted to work with Dr. Wang and Dr. Dunham. Dr. Wang is an associate professor of health informatics at Cornell. He has many years of experience at IBM Watson. I also work with Simon Dunham, who is an electrical engineer and is working on the hardware. These are our current successes. We have won the 2018 Weill Cornell Hackathon. We also have a new patent application for an international approval. And we have NCATS funding and a publication in Head and Neck, which is one of the premier journals in otolaryngology. Our next steps are to further develop our device. First of all, we want to continue working on the materials and the hardware. And we want to collect more data from healthy volunteers and just received IRB approval for it. Another goal is to improve our algorithm as we collect more data. Finally, we want to have a pilot study in the ICU in order to ensure that our device is usable in the ICU setting. Our goal is to apply for FDA breakthrough device application or 510K by 2024. The predicate device would be the electrolarynx. Our ask is for 1.2 million. Please let me know if you have any questions. It was really a pleasure to take part in Equalize, and I want to give a shout out to Kristen. Thank you so much for all your help throughout this process.
Thank you, Dr. Rameau. Jeff, feel free to go first.
Yep, so thank you for that. One of the things that always worries me is when some of the value prop and the endpoints don't feel like they're demonstrable to me. And so I'm just wondering, you noted that you could decrease PTSD with this. You noted you could decrease length of stay and complications in the ICU. Are those actually really demonstrable? And how big a population would you need to randomize to show them? Secondly, and unfortunately, I think the answer to this is no, but I do want to ask it, is there enough EMG signal in ALS patients to help them speak at least for longer during their disease? And I don't know the answer to that, so I figure you do and you can educate me there.
Sure, thank you so much for your questions, Jeff. So to answer the first question, certainly we will need to do clinical studies and prospective ones in the future. Our goal right now is really to have a pilot study in the ICU and make sure that our device is usable and equivalent to existing communication tools, which are extremely limited. After that, we'll have a tool that can allow us to study basically the advantage of giving a voice to patients in the ICU, which is currently inexistent. So that will be a later goal as we further develop this device. Now, to answer the question regarding ALS patients, unfortunately, because ALS affects the muscle activity, we do not include ALS patients as our target users. They will need other solutions, and unfortunately, our device would not be one.
Thank you. Gladys, you have your hand up.
Okay, thank you, and good presentation. 2 questions. One, do you have to customize it, or will you be testing this in the clinical plan as you put it on different patients? Obviously, the different measurements, and just to ensure that you're getting the correct measurements. And then secondly, what is the goal in improving the algorithm? Is it to extend the length of the speech, hear it better, or keep optimizing, as well as keep optimizing the actual language and the coding behind it?
Thank you so much, Gladys, for those questions. So our device uses embedded electrodes, and the design allows for individual placement of the electrodes. Now, we will need a specialized speech pathologist who will place those electrodes on the required muscles of articulation. Speech pathologists are already involved in speech rehabilitation in the hospital, and they're trained in the anatomy of the head and neck, so they would be easily trained in the placement of this device. Now, remind me, your second question was?
Oh, the strategy for improving the algorithm. You said that part of the funding will be for improving the algorithm. Sure.
So one of the challenges for our device is really creating the database of EMG signals, because there are very limited libraries that are open access. But really generating the data requires a lot of work, and we need to expand the vocabulary, but also make sure that that vocabulary is recognizable in multiple individuals. So we do need to collect more data from a diversity of people. And then as the device is being used, we're hoping to also collect that data for further improvement of the algorithm.
Thank you.
All right. Thank you. Thank you, Dr. Rameau.